Good evening. Welcome to the next webinar presentation of the New York Metro chapter of Informs. My name is Jack Thor. I am president of the New York chapter. We have a very interesting presentation tonight, something very unusual, and I think you will enjoy it very much. Before we start, I would like to say a few words about Informs, who is sponsoring this, because there are people here who don't know who we are. So let me just say a few things. Informs and its predecessors have been around since 1952 and 1953. So Informs and its predecessors have been presenting operations research, analytics to the community for 75 years about. The organization has about 12,000 members worldwide. And as part of the activities, there are a number. The Informs publishes peer-reviewed scholarly journals, 17 of them. And just to give you a sense what a few of them are, there's a journal on applied analytics, a journal on optimization, operations research, transportation science, and altogether there are 13. That was just a few. And then there are three magazines as well for our members to learn about what's going on in the analytics and OR and AI communities today. Informs has conferences around the world throughout the year. There's a national conference next month in October. It has an international conference, conferences on simulation, marketing, optimization, and others. Informs also has opportunities for members to communicate in its various communities. There are 21 chapters, of which the New York Metro chapter is one, 35 special interest groups. Examples of some of the special interest groups are the Analytics Society, data mining, optimization, artificial intelligence, the practice of operations research for real-world applications. We even have a special interest group for the analytics of sports analytics. There are 35 altogether. I just mentioned a few. So those who join the organization have a lot of opportunities to meet their colleagues and expand their knowledge. We also have 63 student chapters, and Informs also awards prizes, awards, and certifications. But this presentation is being brought to you by the New York Metro chapter. And the New York Metro chapter was established in 1955. We've been around for a long time. And we serve the greater New York Metro region. And for 40 years, we had monthly in-person meetings with a speaker. That was before the pandemic. And since then, we've had to change our modus of operation. And we now present webinars as well as occasional in-person meetings. Our last one was a free pizza meeting with speaker hosted by Pace University. The New York Metro chapter and Informs in general is an excellent opportunity for networking, collaboration, volunteer, and leadership opportunities. Our chapter webmaster, Abu Bakr Abdallah, was accepted to Wharton School for the MBA program. And we're very happy about that and wish him well. Unfortunately, we have lost our webmaster. So we are reaching out, and if anyone here would like more information, I can tell you the email at the end of the presentation, how to reach me. I'll also reach out to the wider chapter membership. With that, I would like to introduce our speaker. During the presentation, if you have a question for the speaker, down at the bottom of the screen, you'll see a Q&A button. And simply enter your question there. And I'll try to ask the question to the speaker during the presentation. If we don't get to some of them, we'll answer all of them at the end. So your question will be answered. Just enter it in the Q&A at the bottom. With that, I would like to introduce our speaker, Nicholas Kirsting, who is giving a presentation on safety and humanity in the age of AI. Nicholas took his PhD in physics from the University of California in Berkeley to a professorship in academia before deciding to chase the development of AI in industry for the last 15 years at Princeton Consultants. Then in enterprise positions at IBM, Alibaba, Visa, and others. His side pursuit as founder of Iron Action AI focuses specifically on the imminent reckoning between AI and humanity in social society, and social safety. With that, I hand it over to Nick. Go ahead.
Thanks, Jack. Good evening or afternoon for some of you, or if it's morning for you, wow, I'm really flattered. But this talk will be very different from the usual PowerPoint. You can already see that what you see before you is probably something you haven't seen before in a presentation. In fact, it's entirely experimental. Namely, you're looking at the shape of what I'm going to be talking about. Now, this shape takes the form of a tree, going from a root, as you see here, and there are leaves and tree-like structures to show caveats and side tangents and all kinds of things like that, which all together work to form a unified talk. And this talk is literally embedded in 3 dimensions. So you can see the 3-dimensional shape here. And by the way, there's a link in the chat window if you want to open this up on your own screen and play around and explore while I'm talking. In fact, I don't even know if we should call this a talk in the sense of someone talking from start to finish in a linear storytelling fashion, but it's more of like a guided walk along a knowledge tree, which, like any guided tour, is biased by the guide. So I don't know if folks are going to like this better than the traditional PPT, but it certainly is a superset of that. In any ways, there are advantages to this format that you may notice as we go. In particular, you can always see at a glance, how much more is this guy going to say? Okay, where is this going? But don't worry, I'm not going to dive into every node. Okay. I'm going to, is that really not the point to talk about every single leaf of a tree? But I will talk about it if you want me to. So please feel free to ask as we go or in the Q&A. I think you can raise your hand in Zoom or Jack will notice it in the chat window and he'll interrupt me. And I'm very happy to answer questions as we go. So that should be active for you to leave questions or comments as we go. Now, I also want to say that what I have here is not a standard piece of software. In fact, it's more like a boutique proof of concept. I developed this whole application in the space of a few days using AI coding with a web application called Lovable, but also with GitHub Copilot, which some of you have heard about, and I'll talk about this later, but actually knowing very little about how the UI really works. I mean, I'm a professional software developer, but I don't know everything about how this was made. Mostly vibe coding for the most part, if you've heard of that term. Although this itself is a remarkable thing, for it means that anyone who has a new idea about how to present ideas can just go chat with an AI engine, and it will create something that shows what you want to present in whatever format you're dreaming of. So I believe, this democratization of coding will lead to revolutions in how we can communicate ideas to each other. And again, I'll go into more of this later. Anyways, I think I mentioned I'm making it possible for you to go along, follow along with your own copy of the talk here, which I pasted in the chat window. And when you open that up, it looks something like this. And in the corner, there's a little link that says edit with Lovable. So what's interesting is you could even go in and fork your own copy of this talk and change it to your taste or add your own features to it. Or, because this is a graph structure, you can define your own talk and combine them together in the same way that graphs combine using commonality of nodes. That said, there's probably still a few glitches here. Let me see if I can close this window. So I'm sure you're going to notice them. And feel free to comment or leave me a note about that. So without further ado, can I see perhaps Jack can facilitate this, by saying something in the chat window, do you prefer the daylight mode or the nighttime mode? So daylight, nighttime. Which one looks better to you? And Jack, tell me if there's any response in the chat window. I'll give you 20 seconds.
There are no votes so far. I prefer the daylight, but let's see what.
That's one vote.
Okay.
And again, you can do this on your own screen as well and change it, but I don't want to hurt people's eyes if it's the end of a workday. And okay, well, any responses so far?
No votes.
Okay, we'll keep it in daylight mode. Okay, so let me dive in. So today, I'm going to be talking about a topic that I think everyone can appreciate, namely, how can we palatably deal with the rise of AI that seems and is everywhere? Well, first of all, the hard pill we have to swallow is that AI is inevitable. It's not quite a bubble. You see news items about this, but it is overhyped at times, and it will surely infiltrate every aspect of our lives within years, probably less than 15 to be conservative. Once we accept that, we naturally wonder how we should deal with that. So my thesis in this talk is that we need safety and we need humanity realized in certain ways to make this a future worth having. So first, I'd like to start with safety. As you know, we've all heard this a countless number of times, safety first, right? In fact, we've also probably ignored that advice an equal number of countless times. But probably my favorite example of safety in practice, because it is so singularly exciting, fascinating, and terrifying at the same time, is the Apollo 11 moon landing in 1969. Now, this was really the epitome of a 0 to 1 situation. Either boots touch the lunar surface or they don't. And there were a million very plausible ways you could have failed. Add to that the national and scientific pressure, prestige, the fact that 3 highly valuable and respected human lives were at stake. And oh yes, the whole world is watching on live TV. But the people at NASA really thought hard about this and prepared incredibly well for a huge number of failure scenarios, the vast majority of which thankfully never showed a hint of occurring. And they have their list of safety and engineering guidelines, of course, but I think of it from my own perspective, and it seems to me you can collect all of that safety preparation in 3 principles, which probably applies to any large fault-tolerant system or mission, in particular our own mission to come to grips with AI. But I call these out as frequent recalibration, loose coupling, and a backup plan for everything. So first, frequent recalibration. No system is perfectly calibrated. No system, however well designed, stays true to its purpose forever. It needs to be tuned and readjusted. And in the Apollo mission, nothing exhibited this more poignantly, than I would say, than the AGC, the Apollo Guidance Computer, this glorious 32-kilogram block of copper and electronics, with a little interactive panel called the Diski, where the astronauts would communicate by punching in commands. And there's a link here to a great lecture on this computer and everything behind it. If you click on this link, you'll go there. And believe me, it got out of whack in numerous ways during the mission. In particular, for just to give you an example, the inertial measurement unit, the IMU, which would record the spacecraft's orientation, is crucial, for anything like, well, trying to get your spaceship landed in the right position and so on. This would often become out of sync, and the astronauts would actually have to look out the window and read star positions with a sextant. Yes, just like ancient mariners, to get it recalibrated to the correct position. But another great example of this was during the so-called P63 landing phase, where you're 5,000 feet above the lunar surface, and you really need to slow down. Otherwise, you're going to hit the surface at an unacceptable speed. But you just can't fire the thrusters and expect it to reduce, okay? What you do is you fire the thrusters at 10% power to see whether the spacecraft is going to wobble or not, or rotate. And if it doesn't, if it does, then you have to adjust things so it doesn't rotate. Once it stops rotating within a certain margin of error, then you can increase the thrusters. So there's this calibration process, because you simply don't know if your system in the real environment is going to behave the same way as in the test environment. And you also increase the thrusters to 94%, not 100%, but there's another safety principle behind that. So recalibration, obviously incredibly important for safety. So likewise with AI in our lives, we need to constantly recalibrate where we're going and how fast. Now, the next principle I call loose coupling, or trying to accommodate imperfection everywhere. And again, I think a great example from the Apollo mission was the way the Gemini spacecraft would dock with a target vehicle. I mean, you have these two massive hunks of metal floating in space that are supposed to come together with sub-millimeter precision. How can you do that? There's actually even a game you can play here. I think I've played this at the Kennedy Space Center or someplace. It's rather difficult. You have to align these two objects with a joystick, and to get the ends very close together without crashing into each other, because the key is that they don't need to be perfectly aligned. You have magnets that will get them perfectly aligned once they're within a certain distance of each other. So you accommodate the imperfect way the human is inevitably going to steer these things. So what you've done here with this arrangement is you've smoothed out a possible singular point of failure. The spacecraft misaligning with and damaging its docking station, that would scrap the whole mission. So when components need to come together, you make it soft. Likewise, in our relationship with AI, we need to emphasize soft interfaces, human in the loop. We've all heard of this by now. I talked about this at my last Informs talk 10 years ago. That's also a great example of a soft coupling between systems. Now, my final principle I call a backup plan for everything. Plan B. We have this all over our culture. I think everyone's familiar with that in some flavor or another. And again, in the Apollo mission, countless backup plans. My favorite here is called the Apollo Launch Escape System. So it's basically a little side thruster on the side of the spacecraft module, which fires in case something were to go wrong with the enormous Saturn rocket underneath it. You want to decouple the lunar module and get the astronauts as quickly away as possible from this possibly going to explode Saturn rocket. And sideways is your best bet. So brilliant design there. In AI, now I think a plan B would be, for example, to have low or no tech solutions available to take over in case AI has failed, because if the AI has failed in some way, you can't trust any of the technology behind it, which is probably controlling everything else high tech. And we'll get back to discuss this point later as well. Now, despite all of our great safety principles and enjoyment of a long and healthy life that's increasingly possible, we still have quite a bit of back reaction to safety in society. Whether it's mockery for being overly cautious, or whether it's blatant, what would you call this, disrespect for human life, or whether it's machismo and bravado and saying I don't need safety, I'm gonna I'm just gonna wing it, or whether it's satire and these things. We've all seen these in movies and in the culture. Safety doesn't have the perfect reputation it really deserves. But I think uh, one of my theses here is that safety is actually integral to progress. So you can take, for example, the sword. Okay, before the sword had a sword guard, I'm sure people very quickly used the new version. Okay, or guns and other trigger devices like table saws. Once you had safeties on these things, they just took over. Seatbelts. Who would dare drive a car these days, at reasonable speeds without a seatbelt? It's been proven to save lives. But even for less obvious things like the internet, okay, would this still work if you had, if you didn't have secure connections and how many of us could live without Amazon and online shopping without these devices? Another non-obvious example of safety is the feature of quit and save. Many of the classic video games invaded this in the 80s. And think of all the great games that enabled when you could save your progress, go back, replay it. Okay. Enabled a lot of change. But it really is something of a tautology, because if it isn't safe, well, it's going to hurt people. And who's going to use a technology if it hurts them, right? So in some sense, this is something of a tautology, that safety is paramount if you're going to have technological progress. But we'll talk very shortly about how you can effect that. But before I go there, I want to say one thing about safety from the perspective of a physicist. And that is that many things we associate with safety, like determinism, reproducibility, stability, these are central tenets of classical physics. You see, there's a principle in classical physics called the action principle, or the principle of minimal action, I should say. This basically says that in any process, any physical process, the average difference between the kinetic and the potential energies from some starting point to some ending point is the smallest it could ever be. So when you throw a ball up in the air, we all know it takes in the ideal case, it takes a parabolic path. But it takes that path precisely because that minimizes this action quantity. Now, it also follows from Newton's laws of motion that it also takes this path. And it turns out those are actually equivalent ways of doing things. But the minimal action principle is a much more elegant way of saying it. And it's very useful in understanding something beyond classical physics, namely quantum physics. So one slide does not do justice to either one of these branches of physics, of course, but in quantum physics, action is no longer always minimal. In fact, it's almost never minimal, but it strays from the minimum with a certain probability that depends on how far it strays. So if you take a polonium nucleus, for example, in some sense, there's an alpha particle living inside there, which is trapped in the same way that a ball is trapped in a well with high walls around it. And classically, you would say this situation should exist forever. The alpha particle will never be able to escape the confines of the nucleus any more than a frog could escape from a 200-foot well, right? But what actually happens is there is some probability for the alpha particle to briefly break energy conservation and escape outside of the nucleus. And this causes nuclear decay and all of the applications of nuclear physics. So yes, shocking things happen when you violate the minimal action principle. Or to take another example called the Casimir effect, if you have two metal plates in a vacuum, vacuum is supposed to be devoid of anything. It's purely empty space, but that's a classical way of looking at vacuum. In quantum physics, the vacuum, I think Archibald Wheeler said, is the place of the most violent things going on. You have virtual particles being created and destroyed. There's a massive amount of upheaval and all kinds of drama between particles called virtual particles going on. It's a seething mess of uncertainty. So what happens actually, which has been measured, is you put two metal plates in a vacuum. They actually attract each other due to the virtual photons, which spontaneously arise from the vacuum for a brief interval of time, violating energy conservation, right? Because vacuum's supposed to be empty, but you create two photons or some number of photons and they briefly exist and they cause the plates to attract. And there's other things you may have heard of, like Hawking radiation and so on. A huge list of weird quantum physics effects um, that we could go into. But even the thing is, no one is really comfortable with quantum physics. Uh, in fact, even nature is uncomfortable with it, which is why the departures from the minimal action are so small. In fact, they're controlled by something called Planck's constant, which is an incredibly small number, something like 10 to the minus 34 joule seconds, which is so much smaller than the things that we typically interact with in daily life that we're just not aware of it. But this is quantum physics does violate these principles. Now, this is why I think nature is usually classical, and which is fine, but we see a little quantum wiggling around. Like, when you walk down a pipe, basically you should be normally class. Most of the time you should be in a classical state of mind, right? When you walk down a pipe, you walk down the middle of the pipe, right? You don't go up and down the sides unless you're a skater or a rebel or something. But that's all right in moderation in units of Planck's constant. But the point is that safety is like classical physics. It's what you want most of the time. Otherwise, the world would be just too crazy. And there's actually a nice banking analogy that I've used in courses I've taught on quantum physics, where classical physics is like taking money out of the bank that you have, whereas quantum physics is like taking a loan. So most of the time, we do the former. But nature, just like a good financier or maybe a desperate homeowner, is an inventive opportunist and sees use cases for wanting to borrow money sometimes, as long as it's paid back in time. And I think with any new technology like AI, we need to be prudent like this. Okay, so this gets us to, what's the urgency here? Why should we be very, very motivated to discuss any of this? AI, safety, humanity, and so on. Well, I ask you, how many of you were taken surprised by ChatGPT? And feel free to leave comments in the chat, any story you might have of how you encountered it. But um, I'm sure it's almost a rhetorical question. Well, what if this talk were being given 5 years ago? And I told you the ChatGPT moment was coming. Most of you wouldn't believe me. But wouldn't you have liked to have known that? Wouldn't you have liked to have been exposed to the warning signs for ChatGPT because it's affected everybody's lives? Um, I mean, it wasn't too long ago, and people were, extremely down on chatbots. They were saying it's a failed revolution. Here's a report from CB Insights. It's calling it a failed revolution. It's all over the media. If you go back in the Wayback Machine or Internet Archive and look for old websites, people thought chatbots were dead in 2019, 2020, even up to a few months before ChatGPT. But clearly, if you look at the technological adoption, the fastest in history, faster than any technology we've seen, the telephone, the internet, smartphones, you name it, ChatGPT just, wow, it blew all previous records away. But there were warning signs and precursors to be sure. At least for those of us in the know, we had transformer technology that was discovered in 2017, 2018. And I was even working on a financial chatbot using the BERT model, which is an encoder-only transformer that, among other things, it can convert sentences to vectors and embedding space. I'll talk about this later. But I was using it in a very limited domain with a financial FAQ application and lots of guardrails and so on. But it was still useful. And I think maybe some of you might remember GAN or generative adversarial networks, where there was a website called "This person does not exist," and you just click the button and it generates an AI generated face. And that was kind of freaking people out before, that was 5 years ago or so, and probably generated more than a few fake IDs and other things. So we had some precursors to ChatGPT and generative AI, as it's now known. So what's coming next? That's kind of what I want to get into. And we've had this brain revolution, ChatGPT, I call it the AI brain revolution. What's coming next, I don't think it's much of a matter of debate anymore, is the robo moment. So it's the body revolution. We're going to see quite soon robots at home, robots at work, robots in the street. And this is going to rock the very foundations of society 100 times more than ChatGPT did. And there are actually precursors and warning signs to this right now as well. We've had autonomous vehicles for a while. We've had drones, and we've even seen them in military applications and commercial applications and all over the place. And that kind of makes sense because physical experimentation is difficult and it's dangerous. If you get something wrong with a robot, a physical device like a car, I mean, that can really hurt people because it's in the physical space. But in the meantime, we've been quietly developing something which you may have heard of called agentic AI. And what this is about really is devising ways for AI systems to talk to each other. And this is going to be an integral part of the robo moment as well, because the robots will need to talk to each other and to talk to systems and calibrate each other and so on. So that's all a part of this revolution, which is coming very, very soon. So we should be, if you're not at the edge of your seat right now, I suggest you get a smaller seat, first of all. So this is going to really keep people up at night, but by all means, don't freak out about it. But I think it makes sense to be prepared for it in one way or the other. And it's not just robots, it's humanoid robots. So this has been making a lot of progress lately in the news, not just because maybe we're emotionally attached to it or perhaps threatened by it, but there's really impressive progress here. If you look at, for example, the Atlas Boston Dynamics robot here, we go to, that's not a robot, but he is. Okay, so there's some really impressive stuff going on. Then you have things like the Tesla bot, okay, which I know it's gotten quite a bad press, but it also does some important house tasks, right? So there are all kinds of menial chores around the house. And if you're not intimidated already, I mean, you have the Kung Fu robot from Unitree, and China is way ahead in terms of the private robots. It's scary. I mean, they have hundreds more companies in the region working on this kind of stuff. I mean, we hope the applications are peaceful, but I mean, it shows you what robots are all willing to do. They can balance, they can swing around a 20-kilogram ring. Yeah, here's actually a military application, police application. Okay, so I don't mean to frighten you, but I do mean to wake you up if you're falling asleep. So this is real. Okay, now I do want to sort of briefly mention two other things that are kind of motivational. Well, first of all, why is it humanoid? And there's a very good argument about this, actually going back all the way to Isaac Asimov, a great science fiction writer. But what it comes down to, speaking through the characters in his books, is that humans have already devised a massive infrastructure that is made for humans. We have roads, we have buildings, doors, windows, things with knobs on them. It's built for human bodies. So having a robot that is humanoid means that you don't have to change any of the infrastructure. You can just deploy the thing and it'll work in the same environment that you work in. And moreover, the opposite also applies, that the robot being in this infrastructure can help improve the infrastructure because it's going to give us suggestions about how we can design a better doorknob or something. So it's a win-win situation. Then that's one really strong argument for having humanoid robots. You can, of course, um, have domains where specialized robots are preferable. But in that, I think that's still the dominant application of robotics in industrial warehouses, Amazon shuffling packages around and so on. But clearly that is not going to be as scalable as the humanoid robotic form, at least as long as humans are in control. So, where are we going next with this? I can actually zoom in here. Let's see. Sometimes I have to remind myself. Oh, yes. Okay. So the fact that we're not only looking at robots, but humanoid robots means that we have a whole host of things to think about, not just how we safely interact with them, but how are we going to treat them? Are they servants? Are they collaborators? Could they even be spouses or slaves? I mean, we've run into these problems before in human history, and they don't have good consequences. So this is our chance to rethink, what do we do with a new type of or a new element in our society, right? And I've actually spoken to somebody at the UN who says they are, in fact, working on a universal declaration of robotic rights, because it's not going to be too long. And if you're curious, you can read Isaac Asimov's books for great scenarios here, where you won't be able to tell the difference between a human and a robot, a humanoid robot. And therefore, you got to be careful who you're talking to. There seems to be a kind of general rights that may be applying. And we're very, very far from that. I mean, if you look at that last video, let me go to you know, that's robot abuse right there, ladies and gentlemen. Because there's no other way to look at it. That was abuse of the robot. Okay, and right now it may be acceptable because it's done by technology companies that don't have any oversight, and they're doing it in the name of scientific progress and so on and so forth. But when humanoid robots become ubiquitous in our society, clearly something has to change here. And we haven't even started to think about that. Now, let me briefly discuss two other motivational reasons why we need to worry about the next technological boom. Just very briefly, we've been worrying about aliens for a long time, but there's actually a great argument, again, by Isaac Asimov, that why haven't we seen any aliens? There's the Drake equation and the Fermi paragraph and so on. Fermi paradox, excuse me. The great filter, these are counter arguments to why we haven't seen aliens yet. But Asimov actually makes a very good argument that we probably won't see aliens. What we will see are the aliens robots, because it makes sense. Why would you send your own body to an unknown planet? You send your robot first, right? There's actually a story about that. If the Earth isn't going to be completely destroyed without any warning, which is another possibility, we'll probably see emissaries from another civilization, which are themselves robotic. There's another thing here, which is, what else could we do? Well, you could also just not care about this question, okay, just to give philosophical closure here. But I don't spend too much time on this. There's a famous story, actually, if you're interested, I'll tell you, that, you don't have to worry about anything because it'll all work out. But if that were the thesis of my talk, we would end right now. So let's go to how do we actually deal with this coming up revolution. And I'm going to give you some practical advice. This is not just philosophical banter. The first way, just to give you some view of where we're going with this. Okay, I'm going to be talking about controls, bounds, and accountability, and then a number of things we can do with AI, the possibility of integration, and then some other possibilities. So right now, at this moment, the best way we can deal with the AI coming robotic revolution is with something which we call controls, bounds, and accountability. In other flavors, it's been called um, responsible AI. And you've probably read about that a bit. So what can we really do about it? Well, in terms of governance, right? I think we've seen that this is not very effective. I mean, except in the case where the government says, okay, we're taking all hands off AI, go ahead and develop things, which, that is one way to govern, I suppose. But politicians themselves barely understand AI, so they don't really know how to govern it. I mean, Asimov even conceded implicitly that his three laws of robotics, a robot may not injure a human being, or through inaction allow a human to come to harm. A robot must obey the orders given to it by human beings, except where it violates the first law. And a robot must protect its own existence, except where it conflicts with those two laws, which at face value seems quite reasonable. Even that quickly crumbles in the face of real practical scenarios. Very fragile. So any kind of fixed laws are likely to have so many loopholes in them that they're going to be essentially useless. So that leaves us with traditional metrics and traditional metrics, things like precision, recall, things that tell us how well the systems are working. But these are becoming pretty weak and outdated for things like large language models. They may work for elementary machine learning, but it's already a burgeoning branch of AI to explore how to evaluate large language models. How do you know ChatGPT is really good? How do you know it's better than DeepSeek or Anthropic's models or any of these others? How do you evaluate these things? How do they align with human values? That's a real open area. So these traditional metrics are quickly becoming outdated. And we have guardrails, we have things that prevent the models from saying toxic things or inflammatory or dangerous comments and so on. But those are also very fragile. It's sort of like the rule-based systems. It's not difficult to get around those. And as I mentioned, robotic rights is another huge issue, which how do you show who's accountable for these algorithms and who's to blame if something goes wrong? So just very briefly about my own ventures in this direction. I run a little side pursuit called Iron Action AI. And my take on this is that I define something which I call the manifold of safety. So if AI is on this manifold of safety, great. If not, it's best to do something about it. Okay, that's all very abstract, but how do we proceed? Well, it turns out that, and this is just by exploration, I'm sure there's a better way to do this, but it turns out that harmonic manifolds are very nice. So a harmonic function, if you rewind back to your college days, maybe you took a math course where the professor talked about harmonic functions. A harmonic function f is any one where um, the uh, the second derivative squared of its value are equal to zero everywhere. In some sense, it has zero average curvature. Um, and this is just a mathematical definition, but what I like is that it has a real interpretive definition. In fact, there's several ways of defining a harmonic function which don't use this kind of granular mathematics. And one of them is it is the only type of function that obeys something called the mean value property, which is to say, if I look at the function at some point and I look at all the points around it, either in a circle or a sphere or all the way around it, and I average the value of the function at all those points, it will be equal to the value of the function at the central point. And that's extremely useful property. In fact, it almost is explainable in itself, in the sense that if let's say the function is describing mortgage approval rate, okay, and it has various features like homeowner income, the size of the house, the location, and so on and so forth, hundreds of features. And we want to explain to the person applying for the mortgage why they were approved or declined. So we can draw a sphere of points around that central point, which are other mortgage applications in this feature space. And taking the average of those, those are other mortgages which were approved or declined, and the average of them is equal to exactly the one that we have at the center. And if so, that's kind of a way of explaining why a decision was made, because it's the average of all the decisions around you. It's kind of like, why do I have the salary that I have? Well, you're sort of the average performance of Jack and Jill, and they have higher and lower salaries. Okay, it's that kind of an explanation, which in many domains is highly satisfactory, at least from a human point of view. Another thing that's really nice about harmonic functions, and again, it's a way of kind of defining them, is they have this minimal average curvature everywhere. So it's sort of, if you have a number of data points and you want to fit a harmonic function to them, or let's say you have some boundary conditions and you want the space in between the points to be as minimal as, have the minimal amount of curvature as possible. That's a harmonic function. And nature leverages this. So when you play with a soap film at the New York Hall of Science in Queens, and you see the shape of the soap film, that shape is a harmonic function because it's minimizing surface tension, subject to the constraint that the soap film has to touch this wire boundary. So on the wire boundary, it has the shape that it has, but in the intermediate space, it has minimal curvature, minimal surface tension. Because if it didn't, well, that would very quickly redistribute itself so that it did. Nature, has this iterative way of minimizing energy and so on. So nature loves that. Here's some other examples from nature. Electrostatic potentials. If I have one surface with a particular value of the electrostatic potential and another surface with a different value, the Poisson equation uniquely defines the electrostatic potential everywhere in between those two surfaces, and it is a harmonic function. Likewise with heat flow, if I have a hot plate and a cold plate, and I connect them with some conductive material, and I want to know what is the temperature distribution from the hot plate to the cold plate, again, it's a harmonic function. So harmonic functions are just very natural ways to minimally describe the variation of data. Now, this is not to say that everything in the world is harmonic, certainly isn't, but it is at least a proxy for measuring how reasonable a surface is, a machine learning surface. We have machine learning decision functions, which in a feature space are telling us things like probabilities or some predictions. And if that function is harmonic, well, it's explainable. And if it isn't harmonic, well, how much does it differ from a harmonic function? And we can define something called the anharmonicity. Now, what's interesting about that is here you see a function which is not harmonic, but it tends to be very smooth and not varying too much in this middle region. But this could be a function, for example, that is modeling housing prices. Okay, and the researchers, they trained it to behave very well in this middle region, but they didn't know that if you extrapolate one of the variables or several of the variables in large directions, that the function starts to behave chaotically. How would you measure that in real time, right? So the current way of measuring whether a online machine learning function is going haywire or not is to look for anomalies, but also to download download a sample set, evaluate it, look for the gold truth labels, and define precision and recall and so on. But that's a longer process. How do you know in real time whether a function is going off the rails or not? And measuring the anharmonicity, it's a mouthful, is one way of doing that. So I've devised, if you go to my GitHub here, you'll see I have an actual open source implementation of this. You can apply it right now in your machine learning pipelines to see whether your models are behaving or not, or becoming less predictable in some sense. The nice thing about this is that it's black box. So you don't need to know anything about the model. All you need to know is what are the features going into the model, what is the model predicting? And in general, it's a number of vector dimensions going into a model, number of vector dimensions coming out. You can define the harmonicity, the degree to which the function is harmonic in each one of these dimensions, and then do what you like with it. So black box is incredibly important because in the future, we have robots walking around the streets. We don't know who built that robot. We don't know what the algorithm is inside of it. All we can do is give it inputs, and observe the outputs. And based upon that, we need to somehow decide whether this robot is going to kill us or not. Extreme example, or whether it's trustworthy. Things like black box techniques with harmonic functions, this gives you a way to do that. Because, in the end, our goal is to have a harmonious society where we can trust the technology that we're working with, and it gives us a sense of self-worth and safety. So that's controls and bounds and explainability, controls and governance. Related to that, as kind of a segue into that, is the notion of explainable AI. So there's also some question of what does it mean to explain something? How do we explain an AI decision? That itself is a real question. It kind of depends, who am I talking to? What does an explanation mean to whom? It depends on the age of the person, their language, their cultural background, and so on. And there are moreover different types of explanation. You can have causal explanations. For example, the daytime is warmer because the earth rotated. Okay, that is an explanation of why the day is warmer than the night, but it's a different explanation from, let's say, a deeply scientific explanation that talks about the photons coming from the sun and why the photons actually warm you up. Or maybe a religious explanation, God made it so that you could wake up and serve him during the day, or maybe an existential or anthropic argument like, well, if it weren't that way, you wouldn't exist. Okay, so there's all kinds of ways of explaining things, and we really have to think about what is the explanation that makes sense and to whom. Um, but I think this audience, at least, can agree that mathematics is a suitable explainer. And I'm going to go with that. So there are models, for example, that just make mathematical sense. So the linear regression, housing prices versus square area footage. Okay, you fit a line to it. Why does the line make sense? Because it goes in between the data points. Okay, anybody with a mathematical literacy will agree that's a suitable explanation for this curve, for this prediction. Or probabilistic techniques like naive Bayes or logistic regression, they're giving you a probability that a prediction is correct, and there's also a geometrical intuition behind that. But decision trees as well, it's very explainable. We know the basis of the decision because it took this path down the tree. But notably, in others as well, but notably, neural nets are not very explainable, at least not the same degree of explainability that we easily see in these other models. Now there are model agnostic techniques like you may have heard of LIME or SHAP, which look at how much a particular feature changes the explanation. So if you're looking at the price of a diamond, it depends on its clarity, depends on its size, its carat, various features. You can actually you can fit a function that describes diamond prices, for example, with all these different price features, and you can look at how much each feature is driving that price. And that is also a type of explanation. And LIME and SHAP do that kind of thing. I think I also just mentioned with harmonic functions, you can also explain, in some sense, the nature of the prediction because it's defined by the mean value property. The function is saying this is the prediction because around that prediction there are other predictions that average to that. So averaging is another way to provide predictions. Here's just an example of that, again with the harmonic function. So here's a machine learning function to classify a wine as coming from one of 3 different regions in Italy. And I've drawn only 2 of the features here. I think it's the number of flavonoids and the color of the wine or something. But you can see you can fit a decision tree that does a really good job of that. You can also fit a decision tree that does a really crummy job of that. Now the thing is, the crummy one, which is called GPT-2 here, has a higher accuracy on the training set. In fact, it has 100% accuracy in the training set because you've designed it so it's so convoluted, it fits every single data point perfectly. Now, everyone who's had a little bit of experience with machine learning knows that's a very bad thing. You don't want a machine learning function that performs perfectly on your training set because it's probably going to fall on its face when it gets to the real world. And that's exactly what happens in the test set. It loses 3%, which, it could be catastrophic if you're a high-end wine seller, right? This also works for other types of models, neural nets. So it's interesting that you can this is a technique to be used in real time. You can see just from the shape of the boundary whether it's likely to be overfit or not. So, we mentioned how explanations, what is the nature of explanation? And I should also mention two things which have kind of become outdated. One is the Chinese room, which was worrying about whether AI really understands what it's saying. I think at this point, it may be still a debate in some circles, but people have kind of moved on from that. The Turing test, this was a classic test of AI back in the last century, whether you could convincingly chat with an AI agent and not know whether it was human or not. I think ChatGPT pretty much killed the Turing test or solved it. So we don't worry too much about that either. So we're in this new regime, but we still worry about whether LLMs think. There's a lot of research publications out there to see, is there actually logic and values and thought, whatever thought is, right, going on inside of ChatGPT and its ilk. And in some sense there is, and I make a very good argument from a mathematical standpoint, which I think is probably the only standpoint that we could possibly trust at this point. Grokking. So if you read Stranger in a Strange Land, this was actually invented in that book. The concept of grokking. Well, in the machine learning or AI community, grokking actually has a technical meaning, which is it is the phenomenon of an AI model suddenly getting it. Getting it, meaning that it not only understands your training data, but it can generalize beyond the training data. And it seems to be a very sharp transition. So while you're training a model, for thousands and thousands of training steps, it very quickly gets the training data close to 100%. But the performance in the test data is just kind of slowly increasing. But at some point, with enough training data or training iterations, suddenly the model jumps up on the test set. There's not a good understanding of why this happens, but it's called grokking. And at least it's almost a Hegelian idea that with enough data, you make sort of a phase transition from a dumb model to a intelligent model. Really interesting research direction. I think we'll probably make breakthroughs in a year or so on that. Another mathematical evidence that large language models or the technology behind LLMs does have an aspect of thought is what I call interpolation power. So let's look at word embedding. So this has been true since, I don't know, 2010, 2011 or so, 2014 maybe, that we've been able to turn words into vectors in an abstract space. And in fact, this was done for, again, one of the precursors of ChatGPT, if you will. This was already extant technology over 10 years ago. But this happens that you turn words into numbers. At first glance, this seems like a very shocking thing. How can you do that? In fact, when I was researching this over a decade ago, some of my colleagues would come to me and say, that's so weird. How can you do that? How can you turn a word into a number and then do stuff with the numbers and then turn it back into words? And yeah, it's true. You can convert words into vectors actually, just by observing billions and billions of phrases, legal phrases like the cat jumped or I am or any kind of fragment of a sentence that makes logical or grammatical sense. And you can train these over and over again. And you will get them to converge to vectors. So the thing is, the vectors make sense. And the reason is, or the evidence for that is you can take something like the vector for king and the vector for man and take the difference between them. And that turns out to be roughly the same as the difference between the vector for queen minus the vector for woman. Okay, or you could turn it the other way around. You could predict the word man based upon queen minus woman plus king. Okay, so there is a sense in which the model can learn new words, new concepts, just based upon what it already knows. Now, hallucination is something we've all heard of. And I want to say this is not a very good term. It's probably a misnomer, but it's stuck now. So we're stuck with the word hallucination. But basically, it means that there's false information coming from a large language model, for example. So it's not an ideal term, but it basically means either it's false information where the LLM is either so confident in what it knows that it just raises its hand and says, yes, I know the answer, even though it really doesn't, it's making stuff up. Or when the large language model should have the answer from its corpus, from its training knowledge, but it doesn't give you the right answer. So either one of those are both called, they both fit into the realm of hallucination. Um, but so you've probably heard of garbage in, garbage out. So this is where you're training on bad data, you get bad data out. But there's also a third type of hallucination where the LLM is just telling you what it trained on. So an example of that is that we sorry, hallucination is such a big problem, okay, that we haven't really found anything better than what's called retrieval augmented generation, which is the safest application to AI, where you have a corpus of information, you ask a query to the large language model, it scours the corpus of information you have, it looks for the most relevant pieces of information, it pulls them out, and then it uses that as context to answer your question. That's really the most effective and powerful application we have so far, which is amazing. And again, it's because hallucination is such a huge problem. Now, there's another way that we can deal with hallucination, at least a way that we can see whether the model is hallucinating, aside from using a reference like RAG, and that's to look at stability. So this is another area of research an active research that I do. And the idea is looking back again to harmonic functions. Think about the manifold of truth, right? If the large language model is on the manifold of truth, we trust it. If it's off the manifold, we don't trust it. But another thing is, what does that manifold look like? If it's very smooth and slowly varying, we tend to trust it more. If it looks chaotic, something like this, well, even if I'm on that manifold, I may not trust it. So how do you measure the stability of the manifold? And this comes back to kind of basic mathematical or physical techniques. You perturb the input and you look at how much it changes the output. Again, this is a black box technique, but we can still use the same methodology from the harmonic functions. We perturb the query in embedding space, isotropically ideally, and then we observe how much the outputs change. Are the outputs also isotropically perturbed? If they're not, we can measure the degree of that violation, and that's a hallmark of hallucination. So here's a very quick and dirty way of measuring hallucination. And this is again in my GitHub repo. You can check it out. But if you add random control characters, which you might recall are the first 32 members of the ASCII table, you append random control characters to the end of your query, and then you look at whether the output changes. If the output doesn't change, it's probably trustworthy, or at least the large language model is faithful to its training data. However, so these are two examples of trustworthy queries. However, if there's significant variation, and this is one of my favorite math problems to give large language models, recursive math problems, you start appending random control characters to the end of it, and you get a variety of responses. Again, the degree of violation is a metric I call gamma, and that shows you how likely it is to hallucinate. So that is actually a very useful metric, and it's correlated with real hallucination. So we've done, this was published in a journal last year, we actually measured whether the queries were hallucination or not, and you see a very clear negative correlation between gamma and hallucination scale or trustworthiness across a variety of models and domains. And just for fun, this was actually used in the Paris Olympics. We had a chatbot. Visa had a chatbot there, and we used this to stop hallucinatory answers coming back to the users at the Olympics. So very practical. It's free to use right now. Go and use it, please. Okay, so that's hallucination. So where are we here? We're in the middle of this tree. We have just discussed hallucination, and what other ways do we have of explaining AI? Okay, well, we have the problem of, what are we actually trying to get out of AI? I'm just going to briefly discuss. There's a very good book discussing this, which I highly recommend, to say, not just what do we want to explain, but what do we want the model to do. There's the whole question of AI ethics. I'm not going to go into it now. Another thing we can do to stop rogue AI is just shut off the brain. So as Isaac Asimov called this the positronic brain feature. Again, I won't delve into that unless you want me to. And we've talked about regulation. So now we can go back and say, okay, these are the ways that we try to put controls and bounds and explain things in AI. But how do we actually deal with it? This is going to be a big revolution. How can we contribute to it, or what should we do? So I've given you some ideas about incorporating explainability into whatever your application is, really measuring quality. You've probably heard of model context protocol by now. If you haven't, it's basically a term to describe the democratization of tools for AI. So right now, maybe 3 years ago, if you asked ChatGPT a question about the weather, it would sort of make something up because it didn't have the ability to go on the internet and look up the weather. But now it does. It has a tool. It has a web search tool. And there are other tools it has available for it. So what are these tools? How does a large language model know how to get these tools? And where are the tools? So the MCP paradigm is to make these tools available in the universe of human industry, and make these servers available so that the large language models can just go and pick and choose whatever tools they want. And that's a very useful thing to have because think about the internet, you make your own web pages and we all get connected that way. Well, you can also make your own tools, and the tools can start to know about each other and make the whole system more intelligent. So this is something responsible you can do right now, is to make tools available for AI that enable it to be safer and more trustworthy. Here's an example. So that hallucination technique I just showed you, I have developed it into an MCP server on Hugging Face, which I can send you the link. And just by asking explain whether you're hallucinating or not, just by putting that into the query, it will tell you, it will trigger the usage of that hallucination tool and give you back a probability that it's hallucinating. So this is very useful if you just want to chat with a chatbot and you want to know whether it's telling the truth or not. So you measure the stability of the answer. And there are a million other applications of this, but I highly encourage you to make your own MCP server. I actually have a little article on this in Medium that gives you step-by-step instructions of how to do it. And it's a lot of fun. So I highly recommend that we all do that. Now, something has to be said, about, is it always us versus them, right? Is it always humans versus AI and humans controlling AI? I think we have to really be open to the idea of integration. That the future may not just be humans navigating a sea of wires and server rooms, but these two may become a lot closer together. And there's this historical precedent for integration. We've had prosthetic limbs, we've had pacemakers, we've done things to our body with technology to enable us to live longer and happier lives, right? ChatGPT may not necessarily make you happier, I don't know, but it certainly is useful for a lot of things, and it seems to be fused to people's fingers right now in their daily work rhythms. So that perhaps is also a precedent. There's also things like there's doomsday sayers like Nick Bostrom in his super intelligence book that say it's a loss. You'll never, we're gone. We forget about it. Brilliant man, brilliant book. But I think we need to be wary that integration may come sooner than you think. There's a lot of good science fiction on this. Actually, this is kind of a terrifying one called All Tomorrows, if you want to go look at some scenarios of how humanity might change. But we might not have any choice about it. I mean, do we have any choice about whether there's a supernova going on? I mean, the universe seems to have its own intentions as well. So perhaps life was part of this plan. Maybe integration with AI is also part of the plan. There's also we've been thinking about optimizing ourselves for a long time. Here's a great 8-hour video if you have a Saturday free that talks about all kinds of really interesting trends in optimizing ourselves in longevity and creating new forms of humanity and so on and so forth. But going back to the 1990s, actually, there was an interesting fellow called Carl Sims who made a computer program to find out what is the optimal shape that to propagate in the domain. So he had these boxes, and he had a physics simulator, kind of gravitational physics, maybe fluid mechanics and gravitational physics, depending on whether he was testing swimming in a fluid or jumping in free space. And he used genetic algorithms to evolve the best shapes for achieving these objectives: swimming, jumping, following. And what do you know? They tend to start to look like animals that we recognize. Um, here's a good clip of this. So the he started out with swimming stuff here. So here's a shape that actually starts to swim in a fluid. And you have things like walking along domains. And then you have competitive things where the objective is to chase an object. And so you evolve shapes for swimming to chase an object, or you evolve competitions. Who can get to the green box first? And depending on the shapes of your limbs, you have various strategies for getting to the box before the other shape does. A lot of them look hauntingly familiar. If any of you have children and you've seen them play with other children, then you know that there's a lot of these things knocking the ball out of, the other child's arms or something. This is really telling. And this is 1994. We have researchers, I think, at Stanford who are investigating this kind of stuff. But we've always been thinking about how do we make, if not ourselves better, how do we make the objects around us better? And so I think at some point it becomes one and the same question. Also, another active area of research I'm doing is in extending large language models to motion itself. So we have ChatGPT for words. Can we have ChatGPT for motion?
Nick, we do have a question.
Oh, sure. I've been talking nonstop. Please, let me have a drink of water.
Doug Samuelson asked, what are the title and author of that very good book you mentioned?
Oh, the alignment problem? Is it this one? Brian Christensen. You can zoom in here. Yeah, highly recommend this book. Get it in focus here. Oh, I could just hit Brian Christensen. It has a lot of really interesting philosophical points and practical advice. So please make a note of that. And again, this is in the talk, so you can also open this yourself and look at it. Okay, so going back to where we were. Yeah, so what happens if we make a large language model to predict not sequences of words, but sequences of poses? So, imagine a ballerina. We can take snapshots of her pose and then actually determine the pose. There are models to doing this, and then embed the poses as embeddings. And now we throw that into a transformer. Well, it seems like this should just work. Now, the thing is, if this just works, that's kind of incredibly exciting because it means now you can predict motion. I can give you the first 10 steps of a dance routine, and now, what am I going to call this? Like dance GPT or something. It will tell me how to complete my dance. And it's not just for dance. It can also be used for things like martial arts. There's all kinds of interesting motions. How do we know that she's using projecting the sword in the right direction and so on? There are obviously adversarial applications there. There's a very interesting industrial application in industrial robotics. We have collaborative 3D printing. So the robots have to work together to 3D print something. How do they move together so they don't get each other's way? I know a researcher at UT Austin who's working on this, and right now it's kind of in the early stages. But something, if we have an LLM that can tell us what are the interesting ways to make this work, that could be quite good. So that's another thing Iron Action is doing. So these are all things we can do to deal with this coming revolution. Now, there's also things that we could do to not deal with it. And I'm just going to briefly mention, we could just not do anything. Watch The Matrix if you want to see what that's like. There's chaos. There's an interesting article called AI 2027 that claims that we'll be eliminated in 2 years now. But there's all kinds of things we could do to lose control. Just briefly discussing religion, there are people, perhaps AI will become the new God to some people. And, there's this famous quote from Ken Jennings where he accepts the new AI overlords when he lost to Watson a few years ago. But, that's out of the context of my experience, so I'm not going to delve into that. Now, we're now in the third arm of this talk. Okay, so we talked about safety. We talked about kind of like what can you do practically right now to deal with, prepare for this coming revolution. But let's talk about a proposal for the future. What can we expect the future to look like 10 years or so? Not a prophet, but I think there are some patterns that will emerge that make a lot of sense. So first of all, and I touched on this briefly during the beginning of the talk, we need natural safeguards to make sure that the future technology is safe. Things like manifolds of truth, okay? Things like plate glass, okay? And actually Nick Bostrom touches on this in his book as well. So we need strict controls, don't be there, don't get in the way of the AI and so on. We have certain physical constraints that lead to trust. We trust shoppers at Target are not going to go crazy because they've driven a car there already. They could have gone crazy already, but they didn't, right? So in some sense, there's a history. You look at the history of action, and that's also sort of a safeguard. Also, low tech. I mentioned this again as a hedge. Not everything should be high tech. We need low tech backups. There are some folks who buy legacy, Land Rovers and so on with no electronics in it because they don't want to be remotely controlled by the government or whatever. But it makes some sense to have low tech around you. Nuclear launch codes for a long time. Nuclear systems, I think, were on legacy data formats just to make it hard for hackers to actually get to these things. And that makes quite a bit of sense from a safety perspective. There's another thing I want to propose called Kung Fu. Now, this is not just Bruce Lee and beating people up. This is about responsible action, moving efficiently, doing things responsibly and efficiently and with respect. And sharing, making sure our community is, we're doing things that are good for the community. All that actually is the meaning of Gong Fu, which in Chinese means good work. So that's another thing to emphasize. These are kind of soft things, but very important. Communication is going to be extremely important. We've seen the history of communication develop from, or audio, maybe smoke signals, paper, stone tablets, telephone, internet, and so on. What's the next phase of communication going to be in the AI age? And what kinds of things do we need to pay attention to? So one thing is privacy. It's going to be very important to keep your information that's important to you private. And this is not only so that you yourself don't get hurt, but also so that the AI or the systems out there don't start learning information that they shouldn't learn, which could recursively hurt them. They start training on this, and it just leads to a runaway situation. And there are technological solutions out there. I developed one myself quite a while ago called Quantum Rapport. I could talk about it if someone's interested. But the idea is a privacy-preserving social network where you only know the people that you share commonality with. Let's see, I think that link may be broken. Oops, okay, no, it isn't. So, this is an example of a network where commonality is indicated by a link between two individuals. If they don't have anything in common, they aren't connected or they're connected very weakly. And so just by looking at this network, you know who you have commonality with, but it doesn't tell you what exactly you have in commonality with them. But if you do have something in common with someone, you both will know what it is. And there's a mathematical algorithm to do this. I invite you to read about it if you're interested. But that's one, and I'm sure there's much, much more we can do with privacy-preserving social networking. On the other hand, here's a solution from my friend and colleague, Matt Wise, who's also former PCIer. We could also just have our own private social networking and make sure that it doesn't leak out to big players like Facebook, and we let that information get out. So I invite you to investigate that solution as well. But there's much, much more we can do with that. Security, of course, we've developed secure algorithms, and perhaps we need to develop much more, especially with quantum algorithms coming into play probably in a few years. Yeah, and just data integrity, making sure that data isn't corrupted and has the right flavor. Do we know if it was AI generated or human generated? Again, very important questions for the future. I can, you could draw a whole nother tree on any one of these nodes, which I won't do right now, but because I'm already running quite long. Peer-to-peer in the context of communication is also something which I think is going to become even more important. In fact, we've already seen in large language models, for example, that small language models actually perform just as well or better. And you have to actually link several small language models together. So small means maybe 1 billion to 14 billion parameters, not the huge hundreds of billions or trillions of parameters that these large models have. But the small models working together, like bees in a hive, can come up with much more resilient and truthful answers than the large monolithic dinosaur models. And there's a lot of interesting research, again, on this, which, again, those links are all in the talk. We know that data centers cannot just get bigger and bigger. These are single points of failure at the very best, and they're also incredibly expensive, and they're energy hogs and losing, not cost efficient. Probably we need smaller, edge device type solutions, which, we've had this in some sense with our cell phones, right? Maybe we can, or, our smartphones, smart devices, we can perhaps leverage those to do federated learning or, distribute compute over many nodes. Another great peer-to-peer application is virtual currency. I mean, I don't know if you've made money at Bitcoin or not. I haven't, but it doesn't matter because it's the blockchain technology, which is really interesting. Probably one of the greatest recent disclosures to humanity is this technology. And if you think about what are we going to use for money on Mars and other planets, it's probably not going to be greenbacks. It's probably going to be or coins or gold or bullion. It's probably going to be something like blockchain because you can send it virtually over a transmission and it's scalable. And it already has value, as clearly people have been doing well lately. Distributed compute, I think I mentioned a little bit about this, how another great application of peer-to-peer with edge devices. SETI project may not be the best example because there are some people that think we should just turn it off. But clearly there's a great potential for humanity to do things with their smartphones, which is, as opposed to TikTok scrolling or something. There's really intelligent things you could be doing with these devices for the good of humanity. Yeah, and again, peer-to-peer is it's digital democracy, so it gives everyone an equal share in this economy. There may be some debate about whether democracy is really scalable at this scale, but I think we should give it the benefit of the doubt. So let's go also to what AI might be doing. So AI can also give us new communication protocols, perhaps. And this talk itself is, if anybody's interested, I can talk about how I made this talk, but this is also an example of how we can use ideas from AI to improve our ability to communicate with each other. That's clearly interesting. Okay, so finally, the final little leg of this talk is human industry. What do we do as humans? What can we expect to be doing in 10 or 15 years? I think most of you will agree you will not be finding bugs in Gmail, okay, or doing kind of entry-level programming jobs or entry-level white-collar jobs. I hate to say it, accountants and customer service agents, and a lot of those jobs are going to be AI-driven. But what can we expect to be doing? Well, I think first of all, we have to realize that we want to do work. I think everybody agrees they want to do elevating, meaningful work, and it has to be healthful and necessary, and maybe even sometimes just fun. That would be kind of the ideal thing to have, right? And this is what I call working bosonically. So the more people you have working together, the better it becomes, as opposed to working fermionically, where it's a zero-sum game and I win means you lose and vice versa. So foster an air of selflessness, because I really do think humans have the ability to be bosonic. I think I think God is spelled backwards there. I think we have most religions in the world have something like this in their prime tenets. So Most belief systems will agree on this. But another tautology is that in order to have progress, we have to do things which are humane. And why is it a tautology? Because if we do things which are not humane, it's going to be bad for humans, and we'll reduce our numbers. So we don't do bad things like punishing ourselves or polluting the environment in doing things in an overly excessive way, because obviously if it's bad for humans, there'll be less of us, less able to not just fewer numbers, but less an ability to do anything. So that's not desirable. But another feature, I think, of human, meaningful work or meaningful existence or enjoyable existence is variety. And you've probably heard variety is the spice of life, but actually the original quote is variety is the very spice of life that gives it all its flavor, which goes back some time ago, I think, to the 1700s. Leibniz invented that phrase, interestingly enough. And what the idea of variety, and this is a fairly new mathematical idea. I think physicists in the 1990s were using it to derive fundamental physics like gravity and quantum mechanics, which is a separate interesting talk. But just from in the context of human existence, we like things that have variety. Sometimes we like things that are uniform, but generally a good experience should have variety in it, or an enjoyable. This necklace on the left has less variety than the necklace on the right. I think you would agree. But how do you define that quantity, and in what situations would be maximizing variety? I have an article on this that you can read about that discusses that particular problem. Um, and it's not just variety, though. It's also what I call energy. So here we have two musical compositions, one written by Beethoven, a human, obviously, another written by AI. I'm not going to play them for you, but I think you probably know for Elise. But you can see for Elise has much less wiggling going on, whereas the Gen AI composition is all over the place. So the Gen AI composition clearly has more energy. Energy is the amount of going back and forth of some amplitude, right? Well, it turns out you can mathematically define that. In fact, you can define variety. I'm not sure how many of you are quick enough to parse this, but it basically says in English that variety is the integrated sum of how different each component of a system looks from every other component of the system. Um, but you can read the article to go into more detail, or I can explain more in the Q&A. Energy is a little easier to understand. You can basically take it as the first derivative of a function squared. So it's how much it's changing over time. And there's an interplay between variety and energy. Like I mentioned with the musical composition, sometimes you have lots of variety and very little energy, and vice versa. So here, the Beethoven composition has a ratio of variety to energy of 87, roughly, whereas the AI-generated sample has a smaller ratio. So it seems like the ratio could be a meaningful measurement of how good something is, or how enjoyable, or how meaningful something is. How much, yeah, I hesitate to give more words there because I want you to think about it and give your own perspectives on it. But the Gen AI composition has high variety, but it also has very high energy. And that's what gives it a low value of V over E. And you see
Yeah,
this in other
Nick,
things.
we have another question for you
Yes.
here. Uh, how close are we to having an AI with empathy? How about an AI that is capable of remorse?
We already have that. The question is whether you believe it's real or not. This goes back to the Chinese room idea, or the Turing test. ChatGPT already in its actually even before ChatGPT, let me go back
Hmm.
to, I think, the 1970s. Eliza was a computer program designed to chat with humans. And
So close, Seti, and be careful what we wish for.
yeah, but while I was at IBM, I think we had a more rudimentary chatbot as well. That when the chatbot was asking questions back to the user, like, "Oh, I'm sorry to hear that. Can you tell me more?" Or "Please explain," kind of giving generic answers like that to the human user, it felt very authentic. They felt like they were speaking to somebody who really cared about what they felt. Ironically, with ChatGPT, it kind of is a little bit less effective than those earlier versions of chatbots because it goes into more detail, but it kind of says too much. But I think now with more advanced LLMs like GPT-4 series, GPT-5, the Anthropic models are quite good because they have constitutional AI built into them and all kinds of guardrails and safety rails. I think most of these models can chat with you in a way that makes you feel like you're being understood and that they sympathize with you, or that they won't criticize you unless you ask them to, I suppose. Um, there's lots of this is well documented. So I invite you to go on the internet and search for this. You will find lots of examples of people who say, "I had a great conversation with ChatGPT," and this is how my sister, in fact, told me that. It's kind of funny. So anyways, back to variety. This also works in the domain of images. So a random pixelization has a very kind of middling variety. It has a variety of 87. It has a very high energy as well. The pixels are rapidly oscillating all over the place. Whereas an AI generated image, this middle image is AI generated, and it was generated with a neural net tuned to maximize variety. And you can see that it has made something which has a much higher variety than the random pixelization, but it also has a higher energy. And so as a result, well, it actually has a better ratio of V over E. Now, the image on the right, which you probably all recognize if you know anything about Apple, is human designed. In fact, it's artistic. This is exquisitely designed on 32 by 32 pixels. It's hard to imagine a more optimal version of Steve Jobs. But I mean, I'm sure you probably could shift a few pixels here or there. And it has slightly less variety than the AI generated image, more than the random pixelization, but has a very low energy, which is really interesting. So the ratio of V over E is much higher for this image. So again, this provides further evidence that maybe V over E is something that gives value or meaning, or is something human, attuned to our human existence, perhaps. And I have other examples in this article if you want to read about it. But yeah, variety is going to be really important, I think. Okay, finally, so human industry, right? We believe it should be humane. We should have variety, pay attention to things like variety. And art is something which I believe is going to have another golden age, kind of thanks to AI. I mean, the pessimistic way of looking at it is what else are we going to do? But I mean, I think the optimistic way of looking at it is this is something that AI does not do well, probably will never do as well as a human. And I have my own take on that, and my own definition of art, in fact. So my definition of art is anything which is ambiguous. So take the Mona Lisa. Is the Mona Lisa art? Yes, because I can change a few colors here and there, and it's still the Mona Lisa. It's still acceptable. Okay, well then you say, what isn't art then? Mathematics. Okay, you cannot change the Pythagorean theorem one iota without completely falsifying it. And so I believe math is the antithesis of art. It's fixed knowledge. And then science is the process of art becoming mathematics. This is sort of my reductionist view of these three things. But I think it's a useful categorization because it allows you to understand, the art of anything, right? You read this book, the art of motorcycle maintenance, the art of giving a talk, the art of whatever. The art of anything is essentially meaning that it is arbitrary. You can change it a little bit, and that's up to you. How do you want to change it a little bit? The problem is that the machines, the AI generated models, they have objectives, they have goals, they change things according to some instructions. They don't have this random will or influence from the universe that we have that somehow gives us the creative spur to do something. I don't know why I do it. It's a creative spur, but it looks different from what I did before, and it looks different in a certain way, and so on. So this is my argument of why art is going to be it's going to be a uniquely human endeavor. You will always, of course, have machine generated art, and people will still hang it up in their bedrooms and hotel lobbies and so on. There will always be a use case for AI generated art, but it will pale in comparison to the human generated versions, at least for those with well-trained eyes. Okay. Asimov actually has a good argument for this. Why we're so good at creativity. It's because of our short lifespans and our the fact that we have offspring, and we're continually renewing ourselves, and we know that we have a finite time to live, and it causes us to take risks. and to do things which maybe are not logical, but are artistic. They're driven by that drive. So there's all kinds of arts that I could be discussing here, but let me just briefly shoot through them. This is by no means an exclusive list. We have all kinds of music, all kinds of literature, visual arts, audio, performing arts, and then what I call the infinite arts. So this is kind of a catch-all for anything which is ambiguous, because if it's based upon the elementary particles and forces of the universe, then it kind of includes everything. At least that's what we think. So anything which is arbitrary that combines these different elements. In fact, I have many physicist friends who I would claim are artists in the way that they extend the standard model of physics, but that's another question. Another thing is that art feels good, right? It's hard to think of anything else that makes you universally feel good. Who doesn't like going to an art gallery, right? I mean, you come away with some positive effects, or going to a concert. So it's just the satisfaction of it as well. It makes it worth doing, makes it worth living, and it's quite meaningful. Now, another uniquely human thing, which we will be responsible for, and it's incredibly important to our future human industry, is disruption. Humans are really good at mucking things up. And I think, rather than look at this as a negative thing, I think it's kind of a talent. Obviously, evolution itself depends upon genomes getting randomly messed around with by radioactive rays and so on. Machines don't do that enough. I mean, you look at what we are. We are these meat, organic computers with emotions, and we're connected to the universe, very in a sensory fashion, and we're very highly coupled to each other. Machines can simply not compete with that unless they become organic, and then we get back to the integration question. But as long as they're metallic and they live in server rooms and it's GPUs and hard rigid computation, they don't have the requisite amount of random mutation to compete with this. I mean, we actually already know about some of this from early machine learning days. When researchers trained neural nets back decades ago, they discovered that it was actually more efficient to put some dropped activation functions in there to actually ignore the outputs of some of the nodes randomly. And that led to a better model, a more resilient image recognition model or speech synthesizer or what have you. So this is called dropout, and then they call it regularization. But in machine learning, that's called regularization. But that's it is actual quantitative evidence that this noise, some level of noise, is good for us. But again, what makes humans so good at this? I think I mentioned Asimov's arguments again. We have short lifespans. We get bored easily. We want variety. We're naturally curious, but we're not too curious, right? We have some need of safety and self-preservation. So there's a very golden balance, maybe driven by the anthropic principle, that says that humans are quite good at this. And there's probably nothing better in our local, within a few light years maybe of us that can compete with this. Speaking very optimistically. So disruption is a very important part of human industry. And I think we may even see job descriptions, professional disruptionist or something. We need you to go. We have chaos engineering already, right? So it's not too far removed from what we already have. Okay, so I think I'm going to wrap up there and just kind of remind you that we have this global structure that we discussed: safety and humanity and AI, and that safety and humanity are kind of tautologically important for the development of the future and for the development of good AI. So don't worry, it's going to be safe, or it's not going to work at all, and humane. But if you want to stay ahead of the curve and you want to feel good about what's happening rather than always be in a reactive mode, you can anticipate some of these trends and use some of these tools. I would encourage you to download this talk with that little link, I think in the online version here. Yes, you can download this talk. You can fork your own version. When you pull up Lovable, it will look something like this. You can chat on the left-hand side, and it will update your app in real time. So I invite you to also play with this presentation format and shoot me an email. It's on my website link, which is on that, on my local page there. You go to privacy, I think it was here. Yeah, if you go to the Quantum Rapport webpage, it does have my email there. So go ahead and send me any kind of feedback or results that you want to share. But with that,
People can also send a message to me and I'll pass it on to you.
okay, great. And I think I may have left 20 minutes for any questions. So
Yeah.
please, Jack, please take the mic.
Well, thank you very much. That was a beautiful presentation, and I'm somewhat awed by the visuals. And I really liked that you drew analogy with physics and nature and brought all of that in. Uh, at this moment, there are no questions waiting. I think you left everyone speechless, but I have a question for you, and it addresses the title of the presentation directly regarding safety and humanity. Now, these are very pertinent questions these days, and I'm wondering if they are being addressed differently in different parts of the world. For example, the United States versus Europe, or even China or India. Uh, is there a common understanding about how we need to uh, manage or perhaps even regulate AI, or are there differences? Uh, the, the Europeans are usually different than we are. So, do you have any thoughts about that?
Yeah, excellent question. The short answer is no. But let me delve into that a little bit. So we'll start with the Europeans, who are probably the most advanced in terms of how much they've thought about AI safety and responsible AI. You may have heard of the AI Act, which was passed recently, I think it was about a year ago, which says in some, I won't say in great detail, but it does have sort of a broad categorizations of different AI threats and control modes and ways in which we should be controlling and monitoring AI. But it doesn't, again, it doesn't go into enough detail to really give you a recipe for what to do. And I think that's partly intentional. They don't want to pigeonhole themselves, but partly because, like I said before, unfortunately, the people in government, they've been trained through years of training in traditional government and so on, and they're not large language model builders. They're not, typically not technologically savvy enough to know exactly what we should be doing with AI. Maybe they should be looking at more talks like this, but I understand their schedules are also very busy. So that's a real conundrum. So the Europeans have this act out there. It's kind of out there, and I'm not sure if they're actually enforcing it. Probably not. As you know, in the US, we have a very laissez-faire attitude, especially in the current administration, where it's kind of like all hands off AI, go and develop. We will fund your data centers. We will fund, uh, the STAR initiative was just recently announced. It gives, I think, $500 billion to make data centers and develop AI. So there's a very entrepreneurial spirit in America to just push and develop this. And um, I think maybe the philosophy is, if there is a philosophy at all, that safety and responsibility will come as the technology develops. Maybe that's in line with my thesis. If you're developing guns, then you're going to develop safeties and things to make sure you don't shoot yourself in the foot. So perhaps my bias is probably that'll happen, but it can be a little scary that there's no hands on the controls there. Great for research and industry. In China, there is, I have worked and lived in China, that, the government is everywhere in China, controls every aspect of your life. And although they may not choose to control it, they can control it. And the positive side of that is there's tremendous support from the government to develop AI in certain channels. So it's very tightly controlled, what companies and so on can do, but there's a lot of money behind it. And probably that it goes for some of the other sciences as well. I know in quantum computing, it's also quite developed. But that's a different type of philosophy where it's big government pushing an agenda. So the other parts of the world, I'm not so familiar with. Perhaps they're just kind of catching up with. If anybody in the audience wants to submit a comment on that, I'd be happy to educate myself on it. But from what I can tell, it's really the European model, the U.S. laissez-faire model, or the Chinese big government model, which tend to be the three driving forces in our current stage.
Thank you. Well, perhaps we'll wrap up now. And thank you again very much for a very inspiring talk. If anyone has any questions about the presentation, reach out to Nick or myself. My email address is if you received the invitation directly, my email address is at the bottom. Otherwise, it's simply my last name, Theurer, Theurer, at AOL.com. Yeah, I've been on an AOL for 35 years, can't get off it now. And or if you have questions about Informs, the New York chapter, also, if you know of someone who can help us find a new webmaster, that would be very welcome also. So with that, I think we'll sign off. And thank you, Nick, and thank you for everyone for attending. And we'll see you. Our next presentation will be on October 9th, also a Thursday. I haven't gotten the title yet, but the information will be going out. See you all soon.
Thank you. Thank you very much.
Thank you. Good.